it should be going live momentarily, if not now.
Hello, everybody. Bear with us for a second as we just spin up the live stream.
Do you have any jokes?
Did you know, John, you can see yourself blink in the mirror? We'll be coming up soon. Da-dare, 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 da-dare. Looks like we are live on YouTube.
All right, so I think that is good. So I sent out at least the primary things I wanted to send out.
Perfect. How about a couple of introductions, John?
Sure, let me just pause the audio on this feed so it doesn't interfere. All right, I think we're good now. So, hi, my name is John McMaster, and I am here in my garage where I do a lot of home chip work. Can you still hear me?
Yes, can hear you.
Great. Okay, I've just closed the YouTube video. It seemed to be interfering. Oh, great. So my name is John McMaster. I'm here in my garage where I do a lot of the chip work you might see on Twitter and other places like that. And today, I'm going to talk about using different metals to remove bond wires. And that's part of a lot of larger projects I do, which are mostly centered around reverse engineering computer chips in various ways. How about yourself?
So, hey, I'm Yusuf, a maker, tinkerer, tech enthusiast, and collector of hobbies.
Great.
And I'm looking forward to learning what you got today for us.
Sure. So here's the basic problem. The problem is that a lot of people give me a chip, so say something like this, and they want me to get a nice picture of the dye that's inside there. So the first step is I might decap it using acid, and this isn't the right type of chip, but roughly, you'll get a dye, which looks something like this in there. And the issue is, I don't know if it's easy to see in this camera, but there are very fine wires that connect the dye to the rest of the chip there. And the problem is that those wires, which are usually made of gold, sometimes made out of aluminum, I need a way to remove those to get nice chip images, because otherwise they get underneath the dye, it kind of flops around a little bit, and makes it hard to clean. And so the traditional way that you would remove these wires is by taking very fine tweezers underneath a microscope and very carefully plucking all of these wires off the chip. And that's what I did for a really long time. But there's a couple problems with that. One is if you use metal tweezers, it's really easy to chip the chip, I guess you could say. You'll take the metal, you'll put too much pressure, and literally chunks will fly out of the chip. And so I started using carbon fiber tweezers, which are a little bit better, but you still have to be really careful not to scratch the chip and damage it. And then on top of that, it just can be very tedious. You just sit there for a while plucking all of these. Sometimes they're hard to grab. It's just not a good way to do it. So the question was, is there a more streamlined way, especially if you have hundreds of wires on some chips, that you could just kind of remove them all in one go? And I started talking to some people and looking at some failure analysis books. And one way to do it is using everybody's favorite metal. The recommended way to do this was to heat this up really hot. Yusuf, do you want hot mercury in your garage?
Sure, what could be better than some hot mercury?
So the problem with mercury, as some of you may be aware, is, it's a very volatile metal. Even inside this state, it puts off a lot of fumes. And that's part of the reason why I have it in several bags. And in fact, I usually store this outside. But if you're actually boiling it or getting it very hot, the vapor is just going to be extreme. And people have suggested things like maybe put it in a chemistry flask and cool it at the top to kind of reduce the fumes. But ultimately, it's just a lot of fumes. It's hard to clean up. And I wasn't sure if, as part of standard practice, that was something I really wanted to do. Does that make sense?
Yeah, definitely. I mean, mercury is pretty toxic. So like,
Yeah.
what's the solution there?
Well, so the solution was, I said, I remember from our days at Skybox that we would actually remove gold from some things using solder, because it turns out that solder can actually alloy with gold and dissolve it if you put enough on it. So I started saying, okay, well, lead is maybe not the best thing, but it's very common. I already have a lot of soldering here. It's probably not going to be anything worse than I'm doing right now. That was kind of the thought behind that. So then what I did was I bought a solder pot. This is very high quality. It goes from min to man, not max. I don't know if you can see that in the photo.
And is that an error? Or is actually man a thing?
No, it's just very poorly designed. I'll tell you some more. It's also got this nice scale where it says the minimum is 200C. Well, here's another problem with that.
Oh, I think you just cut out there, John.
And in fact,
sorry, I think you just cut out there, John.
Oh,
yeah. Can you rewind a little bit till 200C?
Sure. So it's theoretically minimum 200C, but it doesn't actually turn on until you get about halfway on the dial. So that scale is just horribly off. It's not even close. So the way that I deal with this is I took a power meter, kilowatt, and I stuck it on here, and I would read the wattage as I would turn this knob. And that would allow me to get halfway decent temperature control on here, which does work. It does work. It has a lot of disadvantages. Does that make sense so far?
Yeah, definitely.
Okay, so could you imagine one problem? If I have a little itty teeny die and I put it inside here, what can happen?
It'll just sink in.
Occasionally, yes. And I wasn't expecting that to start because silicon is much less dense than solder and lead. But for reasons which I still don't understand, if you push it really hard, I guess it maybe just encloses the die entirely and it disappears. So there's actually some chips in here that I just never got out. And I don't know where they are, but they're in here somewhere. So yeah, that's one of the problems. The other problem is just look at how much metal there is here. That takes a long time to heat up. And especially as I'm trying to do very precise operations, sometimes it's really difficult to work with a large volume like this. So that's also caused a number of other issues. And this temperature control is not that good. So are you with me so far?
Yes.
Great. So that's what I've been using for a really long time. And in fact, if you look at a lot of my pictures, when you see little solder blobs, they were done with this device. But recently, I started thinking, okay, what are some other solutions? And one of the things that I'd also like to avoid in theory is there's a large temperature difference between this and what a chip is normally at. In theory, that causes a lot of stress on chips, especially if you're not careful cooling them off. And I have a few examples where I actually have damaged chips that way, but not too often. So what if we could use a lower melt alloy instead of lead? Because there's actually a number of liquid metals. Have you ever heard of gallium or gallium before?
Definitely gallium, not the other one.
Yeah, so I can't remember exactly why I went with this instead of straight, but over here, this is an alloy of gallium called, I might have the pronunciation wrong, gallistan. I'm sorry, gallistan. And this alloy, by the way, have you checked to see if there are any YouTube comments? Because I had to close the video. I can't see them anymore.
No YouTube comments right now.
Okay, great. So anyways, so this is a low melting point metal. It melts around room temperature. I think it might even say on here. Well, anyways, very close to room temperature, maybe I think 80 Fahrenheit or something like that, somewhere Anyways, so this was an idea that maybe if this would work on the chip, then I wouldn't have to heat it so much and I could still dissolve the gold. Does that make sense?
Yes. What about the chemistry here? Do you know the reaction taking place? Is it just any low melting alloy that pulls them up, or is there actually chemical reactions happening that are needed?
So I don't know if chemical reaction is the right word, and this is not my strong point. Metallurgy is not my strong point. I think there's a word which I don't know how to pronounce. It's euetic or something like that. Have you seen that word before?
No.
I think it's called that, and it's something to do with the way that different metals are able to kind of blend together. And I think that some metals are compatible in that way and others aren't.
Okay.
And so in theory, this can work, but it turns out there's a problem with gallium. Do you know what that is by chance? And alloys like this. Have you
Arsenic?
ever put not toxicity, but that's a good guess. Have you ever put like water in a glass? What happens? Like especially towards the top.
It balloons a little bit.
It does, right? You get the meniscus. Okay. Have you ever thought about, you have that interaction, but it doesn't necessarily have to be that way, right? What if instead of repelling from the glass, it would attract the glass? What would happen instead?
Oh, it'll just climb out.
Yeah, and apparently that's what happens with this. It just attaches itself to the die, and it's really hard to get off. And so just not a valid option as much as I would want it to be. And so this was good in theory. It looked like it maybe dissolved the gold, but because it just enveloped the die so much, I just couldn't use this. And so that was the first kind of failed experiment a while back.
Okay. So what was the next step?
So the next step was that there are a few alternative metals. And the idea was that maybe I couldn't quite get the low melt that I was going for, which is close to room temperature. But there are a few other alloys like Woods metal and Fields metal. So what I have here are those two. And I think I even tried Fields metal a while back. Here's Fields metal, here's Woods metal. And these are different alloys. And I think that Fields metal had the same issue as the Gallistan, although this was a while back I tried this, I can't quite remember. Recently, though, I tried Woods metal. Now, one of the issues with Woods metal, though, is it contains cadmium. Do you know anything about cadmium?
It's used in paint.
Using paint. That's actually very good. That was actually not the answer I was expecting, though, but that is correct. Do you use them on your models? Do they contain cadmium in the paint?
Cadmium red's, I think, a very popular red color.
Interesting. Are there any concerns for you using those paints?
So, I think most of the time we have just, in the painting world, they have carried over the names, but they don't really use the original ingredients. So they have newer non-toxic ingredients that are similar to the pigments in like cadmium and a lot of those other like metallic toxic metals.
Gotcha. Okay. Well, I have news for you. This has the good stuff in it. This has real solid cadmium in it. Now, it's not all cadmium, but I think you've hit on the issue here. This is toxic, and it's a little bit hard. I don't quite have a good understanding of the toxicity of, say, lead versus cadmium. But once again, my fundamental argument is it's not as volatile as mercury, and I already have lead in my workspace. So I'm a little bit more hesitant to try cadmium because it is a new toxic substance. But there was a question if this would work, because this does melt at a relatively low temperature. I can't remember off the top of my head, but gosh, I should have looked this up, but it was something very approachable, like maybe 150, 200 Fahrenheit, something in that range, I think, under 100 centigrade. And so I ran some experiments with this, and it does dissolve gold, but there was a problem. It doesn't actually do any better than lead. So as I ran the experiments, it melted at a very low temperature, but it had to heat it up to basically the same temperature as lead to really get any gold to dissolve. So there wasn't really any advantage to it. And in the end, I decided it just really wasn't worth using.
Okay. So what's the next toxic substance you're going to show us now, John?
Well, let me do a small sidebar. Is there was a positive to all this. A while back, I had tried using a heat gun to melt small little amounts of metal. So, have something like a petri dish like this, put some metal in there, and I think I tried to heat it with a heat gun. But I thought in the past that I couldn't get that to work. Well, one of the cool things was I thought that this was lower temperature. It might work well with the heat gun. But I did some experiments, and actually I was able to melt solder just fine in this little cup using this. I hope you can see it over here, this heat
Yeah,
gun down here.
definitely
You
can
can see it a bit. And so the idea is now what I'm doing is I'm turning on this heat gun, heating up some solder to liquid in this cup right here. And that actually allows me to work with much smaller volumes of solder and also get precision control from this heat gun. And so although the main experiment failed, I was able to find out that this actually worked a lot better than I was expecting. So I'm probably going forward going to use that. And I'm going to discontinue using this for removing the gold. And in fact, if you happen to see those Nintendo chips that I posted recently to Twitter, those were all done using this technique, not the traditional solder pot technique.
Okay, yeah, I definitely did see those really nice images.
Oh, thank you. In fact, there's more coming, so stay tuned.
And I liked the analysis some people added to your images with the schematics and
Yes,
stuff. That was pretty interesting how he, drew the schematics on just the bare dies.
there was actually even several people who wanted to do that, and I had to say, I'm sorry, but someone's already taken a pretty solid crack at this. But fear not, there are multiple chips out there. So hopefully if people are interested in that sort of thing, they can check out some of the other pictures posted.
Great.
Nice. I guess I have one small thing more, if you want to see one more little gadget.
Sure.
Is I mentioned earlier that there's this whole issue of gold and aluminum. So the gold wires is kind of what we talked about. There's a lot of ways to dissolve gold. But if instead you have aluminum wires, which are used for various reasons on chips, I wanted a way to also remove those cleanly. And to date, I still pluck those because the issue is there's a protective coating over the aluminum that's really hard to get through. Even if you have something that can dissolve aluminum, say like mercury, I believe you do have to scratch the surface to really get anything in. At least with all the tests that I've done, I think that's pretty consistent. So I've started exploring different ways to get through that coating. And one of them here is I didn't know that you actually could buy aluminum solder. I had never heard of this. I found this quite entertaining. And so I got an aluminum soldering kit and I did some experiments. Unfortunately, though, it's the flux in here, which is this bottle here, which is, by the way, eating away its own label, is unfortunately too corrosive to use on the chips. At least with some quick experiments I did, it just ate everything away, just in the way that maybe hydrochloric acid would do or something like that. So it's not very gentle, and I'm not sure if it'll actually do a lot better than other things I could do. But interesting, though, that you can solder aluminum and you can kind of use this to remove the wires, but it'll do quite a lot of damage to the chip in the process, so not really recommended. So yeah, those are some of the main things. Oh, one last thing. It's worth mentioning, I also have a temperature probe. And although I have the heat gun, there's a significant difference between the set point on the heat gun and the actual temperature of the solder. So in order to get an accurate reading, I will put this into the heat gun to kind of preheat it. And then I will poke it into the solder here and take a quick reading. And then that way I know exactly what temperature the solder is at. Part of the reason why that's important is you want to keep the temperature low enough that you don't burn the flux, because it comes off very easily if you're at low temperatures. But if you burn it, it becomes this thick, sticky, or solid mess that I have to use strong acids to get off.
Okay. That was pretty interesting. So you went through different ways of kind of like using the metals, the liquid metals to pull them out. What about just mechanically slicing them off the surface? Like, is that something people do?
Yes, in fact, I've actually had good results with that as well. One time I took basically a razor, and a couple times you just slide it along the chip. You can get pretty decent results. The issue that I've had, though, at least with older chips, is the chips themselves are uneven. And although the chip itself is pretty strong, it does have little bumps, and the razor can kind of chop off those bumps and damage the surface of the chip. So in order to do it nicely with, say, like a razor, like mechanically like that, you need a way to elevate it slightly above the chip. And so you can make it work, but it's a little bit sketchy enough that I haven't done it a lot. But there are definitely some options there. I've also tried some things like embedding the wires in hot glue and then yanking them off of the chip. That has worked sometimes, but sometimes it's hard to grip the wires. And so it's definitely an open space. There are a lot of options there, and definitely up for suggestions if you had something specific you wanted to recommend.
Yeah, I'm thinking about what else could be done. I guess you do use the little grinding wheels to take off the caps, right? To like shave off the silicon sometimes on the chips.
Yeah, so I would say it's probably out of scope because that's a whole thing. But roughly speaking, the two related operations are I use a milling machine to go a little bit in, and then I use a lapping machine, a precision polishing machine, to take some of the layers off sometimes.
Okay. Okay, maybe
Yeah.
a topic for another video then.
Probably a topic for another video.
Yeah. Well, hey, thanks a lot,
Oh,
John. Yeah, this was
thank you
a
very much.
nice insight into, something that I guess most people don't see. Like even people who work in the chip space, I don't think you actually open them up, need to pull these things out. It's kind of a unique look.
Yeah, I would say based on my limited experience in the semiconductor industry, there tends to be a really big separation between the chip designers and the people that deal with the physical side of things. For example, in the division that I worked in, I found that a lot of the EEs that worked there would never solder anything themselves. They would always get a technician to do it, which is very different than the way that I was kind of trained, to kind of be more, I guess, vertically integrated, you could call it.
Yeah, that's my experience too. Like when I was working on Chromebooks and stuff, we had specialists who would do all of the reworking and modifying the boards and things. And I mean, they are really good. Like they knew their stuff.
Oh, for sure. Yes.
Yeah.
I do not claim to be good at soldering by any degree. A lot of very skilled people out there, and I really appreciate the work they do. Cool.
All right.
Is this
Very
maybe
good.
a good place to stop unless there are any questions from people maybe?
Yeah, I think this is a nice wrap up for the topic, and maybe we can take questions offline as well. Please comment on the video, and we'll try to get back to you with answers. Thanks a lot
Sounds
for
good.
watching.
All right. Thank you very much. See if I can.